All right, this example should be no calculus involved, but it's going to put us in the right frame of mind. It's going to put us into the setting of rates of change, which is what the derivative is. The derivative is the instantaneous rate of change. So let's review what we know from algebra, how to find average rates of change. So this function here, f of x, concave down parabola, right? It's this parabola right there. If I fix the point x is equal to -5, or sorry, x is equal to -4 and x is equal to 2, then over this interval, the function is increasing there. It slows down. It seems like it's neither increasing nor decreasing at 0. And then it starts to decrease, right? So the slope of the function changes based on where I look at it. But I can find the average rate of change by giving myself what's known as the secant line. So the secant line, oh, that was bad. Secant line. The secant line is a straight line that touches your function at 2 points. And that's exactly what we have going on here. You've got your original function and your secant line touches at -4 and at 2. So the slope of that secant line is the average rate of change of the function over this interval. Right, so on average, it changes that much y, and it changes this much in the x, right? So changing y over changing x. Let's find the average rate of change of this function. So the slope of the secant line is changing y over changing x. The y value right there, because it's on my function, right? This y value is on my function. So that y value is going to be f at 2. This y value right there is on my function. So it's whatever the function value gives me at the x value of -4. Right? Change in y over change in x. In fact, what is the change in x? We go from -4 to 2. So 2 minus a -4. All right, let's figure out our y values. If you plug in 2 into the function here, you get -1/10. 2 squared is going to give you a 4. So let's write that as -4/10. Plus 5/2. Let's go ahead and write that as 10/4. Oops. No, I want a denominator of 10. So let's multiply by 5. That's 25/10. Right, that right there is my function value at 2. I'm then going to subtract off the function value at -4. My function value at -4 is -1/10. If I plug in a -4 in for that x value, -4 squared is 16. And then plus a 5/2. Again, I want a common denominator of 10. So let's write that as 25/10, multiplying that 5 halves by 5, top and bottom. All right, now all of that is over. Oops, that's not what I wanted to do. All of that is over our change in x, 2 minus a -4. Let's go ahead and tell ourselves what that is. 2 minus a -4 is 2 plus 4. That's a distance of 6. All right, what's the y value at 2? So if I take 25 minus 4, that's 21/10. So that y value right there is 21/10, or 2.1. I then subtract, what's the y value in the brackets? So the function value at -4. If I take 25 minus 16, that leaves me with a 9. So right there, the function value at -4 is 9/10. Right, slightly underneath 1. I've still got a 6 in my denominator. My numerator simplifies 21/10 minus 9/10. So what is 21 minus 9? That would be what, 12? And then I'll take that 12/10 and I'll divide it by 6 again. That's 12. Actually, let's make the algebra easy. The 12 and the 6 leaves me with just a 2 on top. A 2 over 10 is the same thing as a 1 over 5. So even though this function increases pretty quickly right there, increases medium quickly right there, doesn't increase at all right there, and actually starts to decrease, on average over this interval, the slope of the function is, it goes up 1 unit for every 5 units in the x direction.